Hello, greetings. So we are still on factorization. Like I said, this is our second class on factorization. Okay, the lesson 2. We have 4 classes on this, and now we are going to look into difference of two squares. Let me just tick here: difference of two squares. Okay, so I think we have done that. We have done the expansion of difference of two squares. Okay, and I spoke about it when I say we are going to factorize at some point, and now we are factorizing, and we want to see here, where does it apply? It only applies when the first term and the second term are subtracting each other, but again they are perfect square. So both here, these are perfect squares. Now, when we say perfect squares, it means that they do have square roots. Okay, so they do have square roots. So what you're just doing here, the square roots are going to add and subtract. That's all. So here, what we're going to do here, it means that in the first bracket, we're going to say root of x squared minus root of 49. In the other bracket, root of x squared plus root of 49. Okay, so in this case here, I'm just writing it in this way so that you can understand the whole concept behind, but you don't need actually to write the root here. But what you can just do here from there, you know that what you're going to get here, root of x squared is just x, root of 49 is 7, so it's going to be minus 7. Then root of x is x, root of x squared, sorry, is x. Then root of 49 is 7, so plus 7. That's your answer there. Then in this case again, what are we going to do? Remember what I said, root of 100 x the power 10 minus root of y 8, other bracket, root of 100 x the power 10 plus root of y to the power 8. I'm doing this so that you understand, guys. Now, remember here, when you are looking at root is the same as, let's say we have 8, root of a here. This means that we are just saying a to the power 1 over 2. Okay, so in this case, say for example, let's say we are saying root of a to the power 6. This means that it's a to the power 6 times 1 over 2. This will give us a to the power of 3. So always remember that you're just going to say half of the exponent that you are given. Okay, so in this case here, we're going to say root of 100 is 10. So here it's going to be 10. In the first bracket, root of x to the power 10 is just 10 divided by 2. You get 5. So it's going to be x to the power 5. Then minus 8 divided by 2 is going to give us 4. So here 4. Then the other bracket, 10x 5 plus y 4. Okay, so that's all. That's your answer there. So you can just write from there to there. That's actually what you need to do. From there to there, then you are fine. Now let's move on to the next one. Here, what do we have in this case here? We have got 12, 12n squared minus 75m squared. Now, in this case here, there's something that you need to understand here. We can see that 12 it's not a perfect square. Now, 75 isn't a perfect square. But what can we do to actually get this perfect square? We can find a highest common factor. So we can factor out highest common factor. Highest common factor in this case is going to be 3. So 3 goes into 12 4 times. So it's going to be 4, then 4n squared, like what we have been doing in the last class. Here, minus, then 3 into 75 is going to be 25 m squared. Now we have got two perfect square. 4 is a perfect square. 25 is a perfect square. So in this case now, we can write our answer as 3. So we have got 3. Then you open the first bracket. Root of 4 is 2. Root of n squared is n plus root of 25 is 5. Root of m squared is m. Then here 2n minus 5m. Okay, so remember, whichever way you do, even if you start with a negative, end with a positive, start with a positive, end with a negative, or start with a negative, then end with a positive, still the same thing. Okay, it's the same thing. As long as you're adding the same terms and subtracting the same terms in their order, then you're good. Now let's move on to this one here. what we see now is that we have got x plus y. Remember what I said, when you have this, take it as one term. Take it as one term. Just take it like we are looking at n. Are we together, guys? Just look at it as n, because you don't need to complicate things here. Now, when you look at this one here, or as m, okay, because we have n here. So when you have something like this, you're going to say, okay, how do you get this? We have a root of what? Root of x plus y is just x plus y, okay? Minus root of n squared is n. Then root of x plus y, we have it, x plus y plus n. That's it. We are good to go, because you are looking at this term here and say root of it is actually x plus y. So x plus y, root of n squared is just n. Then that's how you do it. Now let's move on to the next one. Now, when you look at this one again, what we can see is that we have got 9 here. It is a perfect square, x squared is a perfect square, but again here, we have something here, which is x minus 1, which again, it's a perfect square. Now, what are we going to do here? We're going to say, okay, in the first term, we're going to have 3x, then here 3x. There you can use a bigger bracket here, okay? 3x minus, so in this case here, root of is going to be 2. Then you can use a small bracket here. Then we have x minus y, okay? Another bracket. Then you open another big bracket, 3x plus. Can you see where the sign is changing here? The sign is changing here because we're taking this as one term. This whole thing here as one term. Now, here, what are we going to do now? We're going to have plus 2 in bracket x minus y, like that. Then now we can simplify this now and say, okay, this one here is going to give us 3x minus 2. We take negative 2 inside, it's going to be 2x. Then negative 2 times y is going to be plus 2y. Then open another bracket, 3x plus, then here 2 times x is going to be 2x. Then 2 times y is going to be negative. Okay, it's just, okay, negative 2y, okay? Now, in this case here, what are we going to be left with? 3x minus 2x is going to give us x. Then plus 2y. Then here, 3x plus 2x is going to give us 5x. Then minus 2y. So this is going to be our final answer like that. Okay, don't leave your answer before you simplify inside the bracket. And again, when you see something like this, use the bigger bracket outside so that we can be left with a smaller bracket to simplify what you call later. Now, let's move on to the next one here, which is 16mn minus 64m squared n cubed. Now, in this case here, what we can do here is that we can see that 16 is a perfect square. M4 is also another perfect square. But what we see is common. So 16 can go into 64. M4 can also go into M4. So what we can do here, we can see that 16 is out, then M to the power 4 is also common, then again N is also common, okay? When we have that, we're going to have 1 minus, here 16 into 64 is going to give us 4, then here we have got M cancels, then N, we're going to be left N squared. Then in this case here, we're going to be left M to the power 4 N in bracket, 1 minus root of 4 is 2, root of n squared is n, okay? Then 1 plus 2n. Okay, so difference of two squares is only applying on this part here, which we have perfect square and also another perfect square. So always factorize first, then further factorize by by difference of two squares after getting your perfect squares. Okay, so you know how it goes. This is your exercise and you know where to submit. Guys, thank you so much. Don't forget to join and tell your friend to join the Google Classroom and be up to date. Thank you so much. Until next time. Bye-bye.